Thanks for coming. I hope you guys get something out of this presentation. My name's Kirsty, I'm from Peak. We're a company up in Manchester who build machine learning and AI solutions for companies. Today, and I'm just talking about forecasting for business. So I've titled it Forecasting for Business, but I thought I'd start off giving a bit of a background into Peak and what we are to kind of like set the scene for the presentation. And then I'll go into business cases for forecasting, because at Peak we predominantly are dealing with, or our customers are retail and manufacturing customers, so that's why all of our forecasts are applied in a business setting. And then finally I'll move on to the profit model at the end. This is a model that we've come across recently and we found it quite helpful, especially for doing quick forecasts and for people who have never forecasted before. So I thought it would be an interesting model to explain, and I'll go into a little bit more technical detail in the third part of the presentation as well. And obviously there's time at the end for questions, so I'm more than happy to go into more detail in any parts of the talk at the end. So just quickly, what is forecasting? It's a pretty standard definition, but we're just predicting what will happen in the future by gathering and analysing past and current data. So I suppose forecasting isn't anything new to anyone. You can forecast anything from the weather, you can forecast profit, you can forecast someone's health, you can forecast the demand of any item. So basically, why would we be interested in forecasting in business? Well, businesses, for as long as businesses have been around, there's been forecasting in businesses, whether they know it or not. A business needs to know the amount of product they're going to sell in the next month or the next week so that they can ensure that they've ordered enough of that to meet the demand. From the finance point of view, they might want to know how much they're going to sell, how much profit they're going to make so that they can plan accounts around that. The marketing team, they might need to know about when sales are going to be so that they can plan promotional activities or advertising around all of that. So basically forecasts have been built into businesses for as long as they've existed, but retailers just haven't really spent a lot of time or acknowledged the need and the use for them in business settings. But nowadays, especially at Peak, we're finding that there's a lot of companies now who are realising how crucial it is to have good forecasting within the business. I think there's two reasons for that. One is that the margins in today's economy is so small for many businesses that any money that they can make on margin is important, and any money saving they can make is important. And again, competition for customers is really, really strong. So companies need to make sure that they can make as many customers as they can and that they retain them. So typically, I suppose from a data science point of view in a company, it's quite common to hear about the customer-facing stuff, so recommendation systems or hyper-personalisation of marketing. And they've been really successful, and I think companies are starting to realise that you can also use demand forecasting to ensure that customers have a positive experience. Things like dynamic pricing for customers, or making sure that products are always in demand so that customers are always satisfied with their experience. And basically companies can do this using the data that they generate of customers. And trust me, they have loads of data on their customers. So at Peak, our role in all of this is basically that companies want to use this AI technology, but it is a really complex technology, as I'm sure a lot of you know from any experience in optimization or machine learning. And it's hard for a company just to build a team overnight. It doesn't happen. Also, the skills are scarce. It's hard to find people out there with the right skill set to build AI. You need data scientists, software engineers, you need management skills. And so to get all of them in one place and the right people is really hard to do. And finally, and most importantly, the systems aren't ready. A lot of companies have all their data stored in old legacy systems, which aren't set up for any type of machine learning infrastructure, especially because all the data can be in silos all around the company. So at Peak, we've built a platform because we could see that every company is going to need some sort of machine learning inbuilt into their system. And I suppose we kind of like sell the AI system to customers as a type of brain, or like the hub of your business where all the intelligent decisions are being made. But in terms of a practical point of view, what us data scientists use it for is almost like a one-stop shop for every tool that we need. So we can log into the AI system and we can access workspaces for R and Python. We can set up feeds to ingest data from our customers. We can set up orchestrations to get jobs running and scripts running whenever we need them run on a regular basis. And we can build out APIs and send them to the customers. The platform also has a managed service, so there's a whole data science team behind it, plus customer successes. So we're making sure that we can talk to our customers and we can get the business information off them, but they don't need to worry about any of the technical or software detail. So we help them from the start of the pipeline, from ingesting the data right through to the end, to integrating it into their business system. So I'm just going to go through a couple of examples of forecasting that we've applied for our customers at Peak. So the first one, which is a project that's just about to go into production, probably one of our biggest ones, was for a global online fashion retailer. So the problem is that they get about 700,000 items per day being ordered off their website, and these are coming from 200 countries all around the world. And these orders are coming in 24/7, and the warehouse is working 24/7 to send out all these orders so that they're getting to the customers, delivered to the customers at the right time. So it's all about order fulfillment. And basically, the model that we've built helps optimize the whole warehouse, because at the moment, the items get sent out in what's called a wave. So these waves are going out, being released, in, about 7,000 items in a wave, and going through the warehouse in one big group. So and at the moment, there are guys who are in the control tower, and they control what items go into the wave and how big the waves are, so that everything gets picked, packed, and on the delivery trucks and out the door by the right time. So our job is to optimize the timing, the size, and the contents of these waves. Obviously, there's a whole lot of bottlenecks and constraints throughout the warehouse that we had to take into account. And our results are delivered in real time through a dashboard that the control tower can just look at straight away. And rather than a 15-minute decision, they can just look at the dashboard and within 10 seconds know what needs to be waved throughout the warehouse. Obviously, there's a few complications like any project. Because this company was so huge, integrating with them, it wasn't easy. There was a lot of people that we had to talk to, a lot of systems that we needed to understand. And on top of that, all the data that they had that we needed was coming from a third-party logistics company. So we had to deal with the firewalls to get the data through, asking people who weren't directly involved with us to set up views from the data, and doing it all within a tight time frame. And I think most importantly, the biggest complication, which I think we've been able to achieve, was ensuring that the functionality of the dashboard for the end user was correct. Because like in any project, if it's going to fail at the end user, then the whole thing's a failure. But if you can identify how the users need to use it, and you can set it up for them, then it can be a very successful project. And if you want to know any more about this, another data scientist, my colleague Tom Hassel, is talking about this tomorrow in detail. A second project that we've done was for a national hire asset company. So this is all about stock optimization. So making sure that they've got 3,000 products across the UK, across 220 locations. And it was all about ensuring that those product types were in the right place at the right time, and that there were the right number there, so that they never had stock outs. And a customer could go to the depot, pick up whichever products they needed. So order fulfillment was always made, but also that the company didn't have leftover stock sitting around, which is just never used. So we were able to identify the stock that is sitting around, and then they could free that up for cash. So one of the ways that we did this was that we segmented the entire product base into 3 groups. So there were the runners, which are like the core products, the ones that are used, that are hired out the most, and that's where a lot of the revenue comes from. Then there were the repeaters, so those are the ones that have quite a standardised order profile, and then the strangers, which are ones that aren't frequently ordered. And then by segmenting the products into those three groups, we could then identify which group we really needed to target the most and really make sure that we had the order fulfilment the most accurate for. Again, we delivered this to the company using a dashboard at a monthly level, and this dashboard is used by senior management and the day-to-day decision makers as well. Again, there are a few complications similar to the previous project, was that this was a large established company, a lot more established than the online retailer. These guys are a lot more slow moving. They're moving to the digital age now, but they're not an online company. So we had to talk to them and make sure that they could implement what they needed and that they were ready for this big change. For a more technical point of view, the products all had different demand profiles. They were all ordered at different times. So there was seasonality that we had to make sure that we were including the right amount in each product's forecast. Finally, this is a third type of project that we come across quite a lot, especially for food and retail companies, is all demand forecasting and price optimization. So I thought I would cover this because this is where we found the profit model the most useful. So for instance, we could get a company that comes to us with a data set that contains over 200 SKUs and across 200 stores within the UK or beyond. And they're basically wanting us to predict the demand of every single SKU in every single one of these locations. So there's potentially a lot of automation that needs to happen. We don't have the time or the resources to go and fit an individual model to every one of those combinations. And we also needed a solution that encompasses both demand forecasting and pricing. So we needed a new model for that. Most classical forecasting models, it's hard to integrate the two of them. There's quite a few complications from a technical point of view. So demand for these products, especially for food and retail products, is all influenced by seasons, by holidays, by promotions, and also product cannibalisation when a company introduces new products. Also, the sales cycles can vary a lot from different products. You can have some products that make up the majority of sales, and then you can have a couple more products which are barely ever sold, but for some reason they're still sold. And the third and final complication is basically, how do you forecast a new product that you've never seen before? So if a new product's going to start being released next week, how do you know what its selling profile is going to be? So this brings me to forecasting events with the profit model. And what do I mean by events? Well, in the terms that I'm going to speak about today, it's all about promotional activity that a company might put on. But events can also be about Christmas time, Easter, like Black Fridays. In the sense for what the profit model was made for, it can also be around sports events. So there's a huge variety that fall under events. So just to take an example of a data set, this is one time series of a product, and there's a few features about the data set. So you can see that there are these huge big spikes that are occurring. That's probably the strongest feature. And they're all revolving around when these promotions are happening down the bottom. And we've got 3 different types of promotions. There is some seasonality, so wintertime the product sells a wee bit less than during the summertime. And there's a bit of a downward trend as well. It's not selling as well at the end of the series compared to the start. And I suppose another feature as well is that there is seasonality, but that doesn't necessarily mean year on year is the same. So January here has quite a different selling profile to January in 2017. So this is the data set I'm going to apply the profit model to. So it's an open source model. It's available in R and Python and was released by Facebook Research. So they released it because they used it internally, but they found internally there were a lot of times where they didn't have the skills or the experience to produce really strong forecasts. So they needed a model that could do both. It could produce reliable, robust forecasts, plus not needed experienced forecasters, which means that they can pump out more of these forecasts in a tighter time frame. So these are kind of the main things that they needed from the model. It had to be interpretable and intuitive for the interface, so it can be used by non-forecasters. There's a lot of automation, so it automatically filters out outliers. There is actually a parameter in the model if you want to turn that off. And it also has tuning capabilities, so automatically tunes all the parameters. And basically, I suppose this slide doesn't say it, but I've already mentioned it. Its strength is around forecasting events, whereas a lot of the original forecasting models like ARIMA or exponential smoothing, moving average, aren't really built or made for events. So that's where the strength of the profit model comes in. This is what the model's doing. It's basically a combination of additive regressive terms. So we've got 3 or 4 components, 3 main modelling terms. So the first one is a piecewise or logistic growth curve. So this models the overall trend in the data. The next one is a term which just models the seasonality, so the periodic changes. And this can model seasonality at a daily, weekly and yearly level. And then the third term is what's new about this model. So this term here, the H term, models the effects of holidays, which in the profit model language is events, but they call it holidays here. And they can be provided at irregular schedules. So this is kind of what it can do. It can model at hourly, daily or weekly observations, particularly daily, especially when there's a lot of historical data to model on. It can pick up strong seasonalities really well. Can deal with missing observations or large outliers, which can occur a lot in real data, especially if you want to automate it all. It's helpful to have a model that can automatically detect the outliers. Can pick up trend changes, which are really important for business forecasting, because like I say, if a new product's introduced, it could have an effect on other products and their trend could completely change. So the fact that the model can pick that up is really helpful. Can pick up holidays or events, like mentioned. And also it has a term where you can add some heuristics or some business logic into it, because there may be certain products which have a non-linear growth, so they get to a certain point and they reach saturation, so they can't sell any more than that, or they reach maximum demand. So the model can take into account that as well. So this is just the data set again. Got 654 observations. There's 3 different types of promotions running. Can't see there, but they're all at different levels as well. There's one Christmas, which is in here, so that's where sales slow. 2 Easters, and I'm going to use the last 3 weeks as a forecast horizon and use all the data before that to train the model on. So this is, I've trained this model in R, and this is the R code that I've used to do it. So it's very simple and easy to do. So I've got, this is the data set that you need on the left here. This is all the model needs. It actually only needs these 2 columns, the one named DS and the other one named Y. And when you make your data set, it does need these 2 exact column names. And then on the right-hand side is this data set here called holidays, and that's just where you're putting in all your events. So I suppose it's a bit of a new or a different format compared to most models. You have your holiday, which is just the type of holiday that you're having, or the type of event. You can name it whichever you want. Then you have a date that it occurs on, and then you can set a window. So, for instance, New Year's Day happens on the 1st of January, and I'm setting the window to be 1. So the model is going to take into account an effect it has on either side of New Year's Day. Likewise, if you go to this promotion here that was buy one product for £1.88, you can see that promotion ran across 20 days. So you just set up your data, you set up your holidays, and then literally this is all you need to feed it into the model, is set up here with this profit function. You just need to put in your holidays, and there's some parameters here, which I've selected just a subset here to show you some of the options that you have. There's different seasonality options, and it can automatically detect change points if you want as well. And then you just fit it by loading in your data set. It automatically fits for you and tunes all the parameters. And then you just make a future data frame, which is the number of periods you want it to forecast over, and then just run the predict function on it. So this is the output here. This is not actually the native output of the profit model. It does produce a nice output, but just for the sake here, I've recreated it. So you can see the black line is the same time series as before, and the blue line is what the model trained on, so the fitted data. And you can see it's able to pick up these huge spikes really clearly and really well. Maybe sometimes near the end of these big promotions, it doesn't quite reach the spike, but you could play around and maybe add in some more holidays or figure out why there is such a spike at the very end. And then down the bottom here is the forecast. So the red line here is what the profit model forecasted of the demand was, and then the shaded red area is its 95% confidence interval. So again, it's very intuitive and easy to use. And then, these are just a couple of or more documentation on the profit model. You can pull out these components from the end of it, from the fitted model, so these are really helpful to look at, and especially for any data exploratory analysis that you wanted to do on the time series. Just a quick summary. So the profit model we found has been really easy to use. It's very intuitive. It's open source, and it's good for quick, accurate forecasts. And it's very robust in general, so it can handle most types of time series. Cool, thank you.
Yeah, thank you very much.